So we did that lab where we looked at how the ground heated. Sunlight came, heated the ground heated the air. And now we have to ask ourselves, well, what happens to the air when it gets heated?
Yeah, because you have the conversion of light to thermal energy, and then it conducts the thermal energy in the air. And I guess we really need to understand, why is it that hot air rises?
Right, because we know like hot air rises. Everybody knows that, right? But the question is why. And so in order to do that, we're going to do an experiment where we have a parcel of air and in this bottle, Gatorade bottle full of air. I've covered it with a glove just to keep it in. Now it's a closed system, right? And so the question becomes, well, okay, what happens as we heat that closed system? If this air was heated or cooled, we know that the mass, because it's a closed system, we proved this, it's not going to change.
Because atoms can't enter or leave the system when it's closed.
Correct.
So mass is going to stay the same, and then we're going to heat it up in a hot water bath, and then we're going to cool it down in cold water, and we'll see what happens.
All right, let's take a look at that. In order to understand why hot air rises, we have to understand what's happening to the density of the air. To understand the density, we need to look at the mass and the volume. The mass, since this is a closed system, will never change. The cold air and the warm air have the same mass as the air in the bottle that we started with.
Alright, this is the bottle or the closed system being heated up. Notice when it's been heated up, all of the glove inflates somehow. But we got to remember that air did not enter the system. It is a closed system. Now, if we take that same bottle and put it into ice water, you would notice that the glove starts deflating. Except remember that the number of molecules of air is still the same.
That was cool. Let's do it again.
Good idea. Let's go ahead and heat it up again. We take the cold air, we heat it up. Notice how the glove inflates, even though it's the same number of air molecules inside the glove. So we have to ask ourselves, what on earth is going on here?
Hey, let's cool it off again. Check it out. Same number of air molecules, they're taking up less space this time. After heating the bottle, the volume increased. We have more volume. On the other hand, when we cool the bottle, the volume decreases. We have less volume in the bottle. If we have more volume when the air is warm, that means we have less density, because the mass divided by the volume would be a smaller number. On the other hand, cold air has less volume, so it has more density.
This is a model of what the system of the glove and bottle looks like at room temperature. Notice that the arrows show the speed of the air particles, and the air particles are filling up the space of the bottle, but the glove is deflated. When you put the bottle in hot water, it transfers thermal energy to the air particles inside of the bottle. Notice that the arrows are longer. That's because the air particles are moving faster. Notice that there are still 5 air particles in this model. However, they are spread further apart, so they are taking up more volume. That's why the glove is inflating. When the glove is put into a cold ice water bath, that thermal energy transfers into the ice water. Notice that the arrows are shorter, but we still have 5 particles. They are moving much slower. They are also much closer together. The air particles do not take up as much space as when it was in hot water. As a result, the air does not fill the glove and the glove deflates. So if we compare and contrast the closed bottle system in hot versus cold water, here's a couple things that you should notice. 1, the number of air particles stays the same, so the mass stays the same, because in a closed system, particles do not enter or leave. 2, you should also notice that the speed of the particles changes depending if it's hot or cold. When the particles are cold, they go much slower. When they are heated up, they move much faster. Third, you should notice the spacing of the particles in the cold versus the warm bottle. In the cold bottle, the particles are very close together. In the warm bottle, they are spread far apart. So the volume of the cold air is much less than the volume of the warm air. That's why the air particles are able to inflate the glove that has warm air, versus the glove collapses in on itself when it is cold air.
This model demonstrates exactly why hot air rises. Cold air sinks because it has a higher density when compared to the air around it. Warm air rises because it floats. It is less dense than the air around it.
So now go to joinpd.com and input the code given to you by your teacher, and we will debrief as a class.